Hello everyone. Tonight we're going to work with circles and learn about some properties we have using circles. First in section 11.4 we talk about the circumference of a circle. And from earlier work we know that the circumference is the distance around a circle. Okay, and so our circumference, the formula that we got for that, okay, so that circumference formula we learned was either circumference equals pi times the diameter, where if we're looking at a circle, kind of missed the center here. Here's this, this pen does not want to put that spot in the center. Well, center of my circle, and then from the center to a point on the edge of the circle is a radius. Or if I go through the center from one side to the other side, that is your diameter. Okay, so circumference is either pi times diameter, or circumference is 2 pi times the radius. Okay, let's talk about pi. I know I had talked to the students about pi and where it came from. A long time ago they figured out no matter how big my circle is, how big it is, how small it is, if I take the circumference, if I measure the circumference and I divide that by the diameter, we get approximately 3.14, and on. Those decimals, go on and on and on. And they found that for any size circle. If you divide its circumference by its diameter, we get approximately that number. So that is how we came up with, or how mathematicians came up with and gave this its special term, pi. Now, what's going to be important in these sections as we move on, that if you are told to leave a problem in terms of pi, then this is what you want in your answer. You want to have pi in it. You don't want to go ahead and multiply that through. Pi is an exact value. When I use the 3.14, that's an approximation. And so when I get to decimals, that's approximate. So in terms of pi or exact values, means that there should be a pi in your answer. So let's just do one of these. Circumference of a circle, if my radius was 9, circumference 2 times pi times the radius, which is 9. So what I like to tell my students to get in the habit of is to write your problem in terms of pi first. So 2 times 9 is 18 pi. And that's an exact value right there, 18 pi centimeters. Now, if it says to round to in your problem, then you can say approximately and plug that into your calculator, 18 times pi. Some of you will use the 3.14 and some of you will use the pi button, and the answers will be real close. I use the pi button. Check with your teacher and see which one they use. But if you put that in, we get approximately 56.55 centimeters. Okay, so that's A. Now if we do B, we plug in, use the formulas that you know, and then we're going to plug in what we have and solve for what we don't know. Circumference is 26. There's my circumference of 26. So I know that the circumference equals, we're looking for radius, so we're going to use the 2 pi r to find the radius. Okay, so circumference is 26. Plug in everything you know, 26, and then equals 2 pi times the radius. Now to get radius all by itself, we want to divide out the 2 pi on both sides. And so from that problem, 26 over 2 pi, I can do the division, which would give me 13 divided by pi would equal my radius. And this is an exact value here. If we want an approximation, we do 13 divided by pi, and we get approximately 4.14. And so the squiggly equal line is what tells me that this is an approximation. Okay, so let's look at a problem that you are going to see, so I would definitely make sure you know how to do it. Put it in your notes. The dimensions of a car tire we have shown at the right. To the nearest foot, we need to know how far the tire travels. How far does the tire travel when it makes 15 revolutions? Okay, so first thing we want to look at is we're going to find the diameter. Okay, if we want the tire, or if we want the diameter of the entire tire, so this is, we want the diameter across, and let me use a different color, maybe you could see that better. We want the diameter across the whole tire. And so to get the diameter of the entire thing, we're going to have to add all of these pieces together. 5.5 plus 15 plus 5.5, and my diameter is going to be 26 inches. Okay? 2. So now we know the diameter of the tire. Let's find the circumference, because remember the circumference is the distance around the tire one time. So my distance around that tire once is my circumference, which is pi times diameter. In this case we have the diameter, so let's go ahead and use the circumference formula that does pi times diameter. And we're going to get 81.68. And circumference is just measuring the distance around, so that's going to be in inches also. Now, let's look at number 3, the distance traveled. That's an A. Looks like an O. Okay, the distance traveled is going to equal the number of revolutions times the circumference. Okay, the number of revolutions. So how many times that tire is going around, and then times the circumference, so 1 times around. So we get the number of revolutions we got was 15. And then we're going to multiply that by the circumference, 81.68. And when we do that, we get 1,225.2 inches. Okay. Know that this is in inches. And so pay attention to the problem right up here which said to the nearest foot. So we have to convert this. To convert, I'm going to put that over 1 and multiply by a conversion where I have the number of inches on the bottom. That way my inches are going to cancel. Inches on the bottom, inches on the top cancel. And we want to put feet on the top here because that's what I want to convert to is feet. And so we think about how many inches there are in 1 foot. And there are 12 inches in 1 foot. And so if we do this conversion, my answer is going to be 102. I multiply across the top, multiply across the bottom, and then divide. So you're going to divide the 25.2 inches by 12 inches, and we're going to get, and then the inches will cancel. I'll do that in red. So the inches on the top, inches on the bottom will cancel, and I'll be left with feet. Okay, and so that's your answer, 102 feet. Okay, so like I said, I would put a star. Definitely put this question in your notes and make sure you understand how to do it. Okay, now let's look at arc length. And when we're talking about arc length, we're talking about a portion. Let me go back to black. We're going to talk about a portion of the circumference. Okay, a portion of the circumference of a circle. So in the circle, we have a ratio. And let's look at, let me go ahead and draw a circle. Oh, we're going to pretend that's at the center. Where my circle is labeled P, so this would be circle P. I've got point A up here at the top, and we'll call this point B. Okay, and so this is going to be the radius, the legs of that. And so what we get is that the ratio of the length of a given arc, and we would call this, if we're looking for arc AB, it's going to look like this. AB, and it have a little curve at the top, and that's referring to arc AB. And arc length, again, arc means a part of the circumference, a portion of it. So the ratio of the length of the arc to the circumference, and we get this formula. So we get the arc length that we're looking for over the circumference. I'm going to abbreviate. The arc length over the circumference is going to be in the same ratio as the measure of the arc, the measure of it in degrees, over the measure of entire circle, 360. So we look at this and we go, the arc length, the part to the whole length, which is the circumference, equals the degree measure of the part over degree measure of the whole. Okay, let me say it again. The part of the circumference over the whole circumference equals degree measure of the part over degree measure of the whole. Okay, so we want to get familiar with these formulas. We get to know the arc length formula. Here we're talking circumference, so we need a piece of the circumference on the top over the whole circumference on the bottom. Let's look at A. Find the length of each red arc. So from A to B, we here are looking for arc AB. So we want the arc length that we're looking for. And we can either write arc length AB, it's one term, or if you would like variables, give it an X. And so if we're looking for the arc length X, that's the part over the whole. Remember that circumference, and I'll put that underneath in red, is 2 pi r. That's your circumference, 2 pi r. So we've got the part over the whole, 2 pi times the radius, 8, equals degree measure of the part. Well, the degree measure that is cutting out that arc is 60 degrees. That's the degree measure of the angle that's cutting out that arc that we want. It's intercepting that arc. So it's 60 over 360. And then if you remember how we solve proportions like this is cross multiply. So we're going to multiply here. X times 360 is going to equal 360x is going to equal 60 times 2 times pi times 8. And so if you do that multiplication, and I would go ahead and do the 2 times the 8, which would be 16 pi, and then also times the 60 up there. And so that's the formula that you're going to get. Now to solve for x, we can go ahead so that we can do this all in one step in the calculator. Let's divide the left-hand side by 360, and then I'll divide the right-hand side by 360. So those 360s will cancel out, and I'm going to get x equals 16 times pi times 60 over 360. Go up here and get green. Okay, and when I multiply the 16 times the 60, I'm going to get 960 pi over 360. Now, this is in terms of pi, and I would reduce that 960 over 360, and if you look on your calculator, if you put 960 divided by 360 into your calculator, hit the math key on the left-hand side, and then enter, enter, it will give you that fraction in lowest form, which would be 8 pi over 3. And so this is an exact answer right here. That is exact, or in terms of pi. If you put that into your calculator and multiply times pi, I'm going to get approximately 8.37, so let's call it 8.4, and this is in centimeters. Okay, so that is the measure of that little chunk of the circumference. That little chunk of circumference from A to B is 8.4 centimeters. Okay, on this screen, let's do number 4. Let's look at number 4. So I'm going to find the circumference of the entire circle. I don't have the radius. All I have is the part of the circumference from L around the circle to this other side is, and I drew over it, so let's write it, 61.26 meters. And that's the piece of the circumference that this angle right here, the 270, that 270 degrees intercepts. It's the part that is cut out from that 270 degree angle. So what we're looking for on this one is circumference. So let's go back to our formula, which says the part, which is my 61.26, the part of the circumference over the whole circumference equals the degree measure of the part that's cutting out that little chunk, or in this case a big chunk, over degree measure of the whole. Part over whole, part over whole. So part of the circumference over whole circumference, degree measure of part over degree measure of whole. And so in this case, since I'm actually looking for the entire circumference, I don't have to use the 2 pi r. I can leave it as c because that's what I'm trying to solve for now. And so we're going to cross multiply again. C times 270. So I'm going to get 270c equals, and then we'll multiply the other side over here, 360 times 61.26. Let's go back to black. 360 times 61.26. And then again, I want c by itself, so let's go ahead and do 270 on both sides, divide by 270. And then I'm going to get my circumference, right here, equals 360 times 61.26, enter, and then divide by 270. And you should get 81.68. And it was in meters. Okay, so that's the circumference of the entire circle. And if you look at it, that kind of makes sense. The circumference, or the part of the circumference we were looking at here, that part was 61.26, and we just have a little bit more to go. So 81.26 is a reasonable answer. Okay, we had some typos at the top of this one, but this is section 11.5, where we talk about the area of circles and of sectors. So we looked at the area of a circle. We've talked about that before, which is the area formula is pi r squared. And how I remember is that area is a squared unit. And so the formula of area of pi r squared, r is what's being squared, so I always remember that's my area formula. So let's do B here of the example, where if I'm looking for a diameter and I'm given the entire area, you just plug in what you know. The area is 113.1 centimeters. That's the area. And pi r squared. So the first thing we have to do is solve for r squared. Solve for r. So I'm going to divide both sides by pi. Now, one hint for you is that if your problem starts out with a decimal in it, then your answer can have a decimal in it. Okay, so when I do that, I get r squared is going to equal 36. And then to get r just by itself, just one r, I've got to take the square root of both sides, which is going to give me 6. Now, my question asked me for the diameter. And so I have to get diameter, we've got to multiply 2 of those. Radius times 2. And so my diameter is going to be 12. So that's your diameter for the problem. Okay, let's look at sector. The sector of a circle. And what we're talking about with the sector, what we're talking about with sector of a circle is where, again, we're going to cut that into a little chunk. But what we want, let's look at P, my circle P, and we'll give this A again. And this point here we can say B. And what I want this time is the whole area of that chunk. So instead of just a piece of the circumference, now I'm looking for a little chunk of the area. And so my formula is pretty close to the same thing, but I want the area of a sector, and we call it area of a sector, which is a section, a little section of the entire area. But we're doing an area of the sector over the area of the circle. Okay, the area of the circle. Remember, area of a circle is pi r squared. So that's what we're going to put down there, pi r squared, equals degree measure of the sector. So degree measure. Okay, so we want the degree measure of the angle that cuts out that sector. Over the degree measure of an entire circle, 360 degrees. So if you look at it, it's pretty much the same formula that we had before, but this time we're looking at the area of a piece or a section, a sector of the circle over the area of the whole thing. So a piece of the area over whole area equals degree measure of the part over degree measure of the whole. So it's really close to the same formula. Okay, so let's look down here at the guided practice problem. We have the diagram to the right here where we're going to find some measures. On number 1, we're going to find the area of circle D. And so that's how we label it, so you know how to refer to it. A little circle with the dot in the middle and then the capital letter that's by the center point. So this is circle D. And if I want the area of the whole thing, I'm going to use some of this space up here. If I want the area of the whole thing, area is pi radius squared. And my radius in this problem is 14 squared, 14 feet squared. So my area is 14 squared, which is going to give me 196 pi. And remember feet, this should have been 14 feet squared, and we get feet squared. Okay, feet times feet is going to be feet squared. Now, that's an exact answer right there, 196 pi. If I want an approximation, that's when I would go and plug that into the calculator, 196 times the pi button, and I would get 615.75 feet squared. Okay? But again, remember to put in terms of pi or an exact value. You multiply the numbers, but leave pi in it. Don't multiply pi on through. Okay, so let's find the area of the red sector. I'm going to use red to find the area of the red sector. And I'll do number 2 down here. The area of the red sector then, remember the formula, that we do the area of the part. That's what I'm looking for. So let's give the area of the part, we'll give it a red X. And so the sector, the area I'm looking for, we'll call it the part is X, that's what we're solving for, over the area of the entire circle, which we just found to be 196 pi, so the area of the entire thing, 196 pi, and we're going to leave this in terms of pi for right now, equals the degree measure of the part of the sector we're looking for, that angle measure, which is 120 degrees, over 360, the degrees of the whole thing. So here we're going to cross multiply. So I get 360x equals, and then I'm going to do 120 times 196 pi. Okay? And I'm going to have to move up here a little bit. And now I'm going to go ahead and divide both sides by 360. See if I can get that moved in here. Divide both sides by 360. So that way we're going to get my x equals, I'm going to do 120 times 196. Okay, this time I'm going to just plug in everything. 120 times 196 times the pi, and I'm going to hit enter, and then divide by 360 will give me about 205.25. Now this is an area we were looking for. This is an area of the sector. The units of measure here is feet, and so that little sector is going to be feet squared. We get the area is in squared units. Okay? Then we can do the same thing for the blue sector, but if I'm going to do the blue sector, then I'm going to take, okay, if I want the blue sector, and I probably don't have room to do the whole thing, but let's just look at what the degree measure of the blue sector would be. I'm using the same type of formula. The part that I would want is the blue area, so we could give it, say, a y. And instead of the 120, I'm going to do 360 minus the 120 to get the degree measure that I'm looking for the blue sector. And that's going to be 240 degrees. And so that would be the degree measure that you'd use in your proportion. Okay, let's do number 5 here. We're going to find the area of the entire shaded region. And so I need to look at these things and divide them into pieces that are manageable. So if you look at this side right here where the half of a circle is, I know I'm going to need the area of a circle, but I only want half of a circle. And so the first thing I'm going to look at is the area of half the circle, and then to that I'm going to add the area of the triangle. So I'm going to abbreviate that, well, put the symbol in for a triangle. So the area of half a circle. So let's take a look at what a circle is. The area of a circle is pi r. Now look at what my radius is here. If the diameter is 7, then my radius is going to be half of that. And so we'll use pi times the radius, 3.5, half of 7, 3.5, pi r squared. But remember, I only want half of that, half of pi r squared. And to that, I'm going to add the area of the triangle. So if I look at the triangle, I have a right triangle there, and a right triangle, there's one side is base, and one side is my height. Remember that I'm looking for a perpendicular line going from a base to a vertex. And so this is 1/2 the base, which is 7, times the height, which is 7. And so the area, the total area of the figure, if I do on the 1/2 pi 3.5 squared, and what do we do first? Well, we would do this 3.5 squared first, order of operations, exponents first. And then I can multiply by pi and divide by 2. I'm going to get 19.24. And to that, I'm going to add 49. 7 times 7 is 49. Divide that by 2, and I get 24.5. Now, these are in meters. When I found area, these are both meters squared now. So if I add those two together, I'm going to get 43.74 meters squared. Okay, I'm going to move to one more screen and do one more example.